Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you the turning of a car in circular path. That is circular turning of a car. That is main topics is banking of smooth road, banking of rough road. So today's topic is circular motion. Circular motion and main circular motion. The today's topics is banking of road, smooth, rough. Two case I will discuss, and turning of a circular turning of a car. Circular turning of a car. First I discuss circular turning of a car. Circular turning of a car in plain road. In plain road. Plain rough road. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. Today's topic is circular turning of a car in plain rough road, and also banking of road. What do you mean by banking of road? I will teach you in smooth and rough road. Now first discuss the circular turning of a car in plain rough road. When a car turns in a plain road, that is the plane is not inclined. Suppose the car turn in a this type of, this is plain road, plain, not inclined. Now a car, suppose a car moves in this road, in this plain road with velocity v. Suppose this car turns in a circular plain track, circular plain track. This is not inclined, this is plain but car in circular path. So when this car turns about the circular track, maximum safe speed to turn in circular track. If the car exceeds that speed limit, then the car will skid. Skid means wheel is not well in contact with the ground. This will not take the turn and it will slip and it moves in this direction, straight direction. So that is called skid. So for safe turning, what is the maximum velocity of the car? For safe turning, find v max. First I discuss this. Now if the car turns with velocity v, what is the centrifugal force act? Centrifugal force act outward, which is equal to mv square by r, For this the car will skid outward, the car will topple outward. So the friction resists this motion. So friction equal to what? Friction equal to mu into mg, maximum friction force. So for maximum speed, maximum friction force acts. Now for no skidding, what is the condition? Condition is that friction must be greater than this. Friction must be greater than equal to mv square by r. That is, this force should less than friction. If this force is maximum, then car will turn in this direction outward. So this will not well contact with the ground. The wheel is not well contact with the ground. So the car cannot turn in circular path. So this will skid. Skid means it topple. It moves outward direction. So this is topple and it moves in this direction. This phenomenon is called skid. So for no skidding, safe turning is f greater than equal to this. So what is f? F equal to mu mg. This cancel m. So v square less than equal to mu cancel, not mu. V square mu rg, that is v less than equal to root over mu r g. So this is the maximum speed. Maximum speed for no skidding is this. This formula comes in NEET exam. What is the maximum speed for no skidding? So answer is V maximum will be root over mu r g. So velocity of the car should be less than equal to this for safe turning. Okay, fine. Here friction must be greater than this. If this force is greater than maximum friction, then this will topple outside. That is, the car will topple outside. So this will skid. The circular track is outside high than the inner side. That is, this is circular track. Though the circular track is outside, that is outside, this side is higher than the inner side. So that is, this plane is something inclined. Suppose the metro track or the path for climbing the hill, this path is in circular track, and metro track is circular, and this track is inclined. So what is the purpose of inclination when the path is in the form of circular track? I will discuss why the track is kept outside higher than the inner side. Suppose a car turns with velocity v along this road. Now, what is the different force acting on this car? First, weight act downward. Now, what is the normal reaction? Normal reaction is along in this direction. Now, what is normal reaction? Normal reaction is normal to the surface. This is the surface. So, normal reaction act normal to the surface. This is normal reaction. This angle is 90 degree. Normal reaction. Now, we resolve n this and this side. This is, if this angle is theta, then we can show that this angle is theta. This angle is theta. This is vertical opposite. This angle is theta. Now, a component of n along this direction, vertical direction, is n cos theta, and in this direction component is n sin theta. Now, if the car moves with velocity v, what is the centrifugal force? Centrifugal force act in this direction, mv square by r. So to balance the car, that is, to balance the car for safe turning, this velocity, this force must be equal to this force. So mv square by r should be equal to n sin theta, and mg should be equal to n cos theta. N cos theta, the component of n is along n cos theta, and component of n along this direction is n sin theta. Now, here this force provides the necessary centripetal force. Now, n sin theta equal to centripetal force, and n cos theta balance the weight. Because mg act in the direction, so this will be this, because there is no motion along this direction. So n cos theta must be equal mg. And when the car turns, so as it is turned, then a centripetal force is required along this direction. A centripetal force towards the center. A centripetal force is required towards the center. So which force provides the necessary centripetal force? This force provides the necessary centripetal force. So n sin theta will be centripetal force, we know, mv square by r, or you can assume that the centrifugal n sin theta balance the centrifugal force. Centrifugal force is pseudo force, so we cannot realize from the ground this force. If a man is sitting in the car, then he can realize that a outer force acts on the car. So this force is pseudo force from inertial frame of reference. What is inertial frame of reference? That is, a acceleration equal to 0 is inertial frame of reference. From this centrifugal force act in this direction. So this force balance this force. So you can assume this equal to this and this equal to this. So So to balance this force, n sin theta balance this force, and n cos theta equal to mg. So 1, this is 2, so 2 divided, so 1 divided 2, which is equal to v square by rg equal to tan theta. That is v equal to rg tan theta root over. So if v equal to root over rg tan theta, then friction equal to 0. This is the important points. So if v equal to rg tan theta, friction should be 0. Now if friction here equal to 0, friction on the car is 0. Now for rough inclined plane, rough banking road, so draw angle of inclination is theta. Suppose a car, the car turns in circular track in rough inclined plane with velocity v. The here question is, what is the maximum? Find v max and v minimum for safe turning. Find v max and v minimum for safe turning in rough banking road. Banking means that road is inclined with the horizontal. This is the banking road. Now the road is rough, that is there is a friction between the road, there is a friction in road. V max and minimum for safe turning of the car. Now here, what is the different force acting on this car? I will show. Here velocity is v in this direction, so here first draw the normal direction. Normal direction is in this direction, this is normal direction, and weight acts in this direction, and here centrifugal force act in this direction, now friction act along the friction act in this direction and also this direction. So at which direction friction acts I will discuss. If velocity is less, that if v is less, that is with less velocity, when velocity is less, then this force is less, then due to weight of the car it tends to slip this direction. So friction prevents the slipping of the car. If the velocity is less, then this force is less. So this force is less, but weight is max. Weight, due to the weight, the car tends to slip, and the friction act in outside. Friction act opposite direction prevents the slipping of the car. So when velocity is less, friction acts upward along the plane. Upward means this side, not this. But this is not vertical upward. This is upward along the inclined plane. Now, if at a velocity v equal to root over rg tan theta, at the velocity friction force equal to 0. Now, if the velocity is maximum, then this force act in this direction. So due to this force, a component of this force act in this direction. So due to this force, the car tends to move in upward. So friction now adjust friction will adjusting force. Friction is adjusting force. Friction always prevent the slipping of the car. Friction always prevents the slipping of the car. Friction is always adjusting force. Now when the speed is more, then the car tends to slip along this direction. So friction automatically act along this downward, prevent the slipping of the car. So friction can friction can act in this direction, also this direction. When velocity is less, friction act out this direction, and when velocity is more, friction acts in this direction. First I consider the velocity is maximum. So first find we v maximum. What is the maximum velocity for which the car can take the safe turn? Now maximum velocity means the friction can prevents the car with the maximum force. Maximum friction force equal to mu into n. Now as theta is constant, so n is constant, which is n equal to what? N equal to mg cos theta. This is n equal to mg cos theta. So n is fixed as theta is fixed. Maximum friction force, so maximum friction force equal to mu into this. Now when we apply v maximum, we apply also maximum friction force. If v is less, then friction also less. So when we apply v maximum, we use maximum friction force. This is point to remember. Now v maximum, so for v maximum, find the v maximum. We friction force act in this direction. Friction force act is, now we resolve the different force along horizontal and vertical. So now this is theta, so this is theta, so this value is f cos theta, and this value is f sin theta. This is f cos theta, this is f cos theta, and this is f sin theta. Along this direction, this is f sin theta. So we resolve f along two direction, which is, now this is the friction force, this is angle theta. So we resolve the friction force along two direction, horizontal f cos theta and vertical f sin theta. Weight act in this direction. Now we resolve n along two direction. This is theta angle, so this angle is, this is n cos theta, and this is n sin theta. So we resolve n along vertical and horizontal friction force, we resolve along horizontal and vertical. Now what is the equation? Equation is n cos theta will be f sin theta plus mg. N cos theta will be f sin theta plus mg. This is equation 1. Now we calculate the maximum velocity. So here we can use n cos theta equal to mu into n sin theta plus mg. Now this plus this force balance this force, so n sin theta plus f cos theta equal to mv square by r. This is equation 2. Now here if put f equal to mu n, so n sin theta plus mu into n cos theta equal to this, okay. So now from 1 we can see that n cos theta minus mu sin theta equal to mg, and from 2 n sin theta plus mu cos theta equal to m v square by r. So this divided by this, 2 divided by 1, as this divided by this, we get sin theta plus mu cos theta divided by cos theta minus mu sin theta equal to v square by rg. So v equal to rg root over rg of sin theta plus mu cos theta by cos theta minus mu sin theta, which is equal to root over rg into, if we divide by cos theta on numerator and denominator, we get tan theta plus mu by 1 minus mu, if we divide by cos theta, mu tan theta. So this is the answer. Maximum velocity, we get v maximum. This is the formula. So if mu equal to 0, we get v equal to root over rg tan theta. So when friction is 0, then velocity is, when velocity equal to root over rg tan theta, then friction mu equal to 0, that is friction equal to 0. So if we draw the diagram at here friction force act in this direction, for minimum velocity. So for convenience, just if you find the maximum velocity, then just put minus mu in place of mu, minus mu in place of mu, that is minus mu and minus minus plus. So this, from this we get the minimum velocity. Now if we can derive this minimum velocity by the diagram, act in this direction and mg epsilon now friction, what is the different force acting on this? So friction, now F, this is theta, so this angle is theta, this is theta, so this is F cos theta, and friction force this F cos theta, and this is F sin theta, this is F sin theta. So now resolve the friction at this and this direction. Now n cos theta plus friction force F sin theta. So F sin theta, if the friction force act this, then we can resolve friction this and this. So here F sin theta absent, so here n cos theta plus F sin theta balance the weight, and mv square by this plus this balance n sin theta, and mv square by r plus f cos theta equal to n sin theta, okay. Now put mu f equal to mu sin theta, f equal to, now put f equal to mu n, because minimum velocity means maximum friction force act in this direction, so velocity is minimum, because so put f equal to mu n cos theta plus mu sin theta equal to mg and mu n. So if we shift here n into cos sin theta minus mu cos theta equal to mv square by r. So if we divide this, then v square by rg, we get v square by rg. If we divide this by this, v square by rg equal to this by this, that is sin theta minus mu cos theta by cos theta plus mu sin theta. Now if we divide by cos theta, we get tan theta minus mu divided by tan theta minus mu divided by 1 plus mu tan theta, 1 plus mu tan theta. So rg multiply here, so v equal to root over rg into tan theta minus mu by 1 plus mu tan theta. So this is the minimum velocity, this is the minimum velocity, this tan theta minus this and this same. So this is the minimum velocity. So when velocity is minimum, friction force act in this direction, because this friction now prevents the slipping of the body, slipping of the car downward, because velocity is minimum means this side force is minimum, centrifugal force is minimum, so the car tends to slip due to this weight. Now friction just prevents the slipping of the body, so friction act in this direction. Now what is the minimum velocity? This. If the velocity is increased at a particular velocity, root over rg tan theta, so if v equal to root over rg tan theta, then friction equal to 0. This is at this velocity friction is 0. Now if the minimum velocity and maximum velocity, friction is maximum, just reverse the friction, reverse its direction, so that the car can safely turn. That means the car cannot slip along the inclined plane. So this is a question, this is question, a turn of radius 20 meter is banked for the vehicle of mass 200 kg going on a speed of 10 meter per second. Find the direction and magnitude of frictional force acting on a vehicle if it moves with a speed 5 meter per second, moves with 10 meter per second and 20 meter per second. So three case at 3 velocity, find the direction and magnitude both of frictional force. Car turn in this direction. Now draw the picture. You practice to draw the picture. Now what is the normal direction? Normal direction act in this direction. In which direction? Normal direction is always draw the perpendicular of the surface, okay, not this perpendicular, this is the inclined plane, so draw the n perpendicular to the normal surface. Wait, what is the weight acts vertically downward, weight acts vertically downward. Now consider the velocity is less. Velocity is less means in which direction friction act? Friction act in this direction. Friction act along the graph plane outward, that is in this direction. Now this is the main force. Now remember, resolve this and this along horizontal and vertical. So this is vertical, this is not the resolve by mg will not required. So n and f, resolve n and f along horizontal and vertical. So along horizontal and vertical, if we resolve this, so this angle is theta means this angle is theta, this angle is theta. So the component of f cos theta, and this is f sin theta, and n, this is n, this is theta, this is n cos theta, and this is n sin theta. Okay, so draw so resolve n and f along horizontal and vertical. Remember this, along horizontal and vertical. Now we balance this equation with this plus this, balance the weight. So f sin theta plus n cos theta balance the weight, and f cos theta. Now a centripetal force, now a centripetal force also act in this direction. A centripetal, sorry, now a centrifugal force also act in this direction, mv square by r. So three main force: normal direction, friction, weight, and centrifugal force act in this direction. So just weight acts vertically, centrifugal force act horizontally. This force cannot, this force don't, this force are not required to resolve, only n and f have to resolve, n and f have to resolve along horizontal and vertical direction. So what is resolve? N is n cos theta, n sin theta, f is here f cos theta and f sin theta. Now this plus this balance weight, and mv square by r plus f cos theta balance the n sin theta. N sin theta. Now simplify this. So for v equal so now first calculate at which friction is 0. If we calculate v equal to root over rg tan theta, if we calculate rg tan, what is r? R is 20, g is 10, tan theta equal to half. So this is 10 meter per second. So now v less than 10 meter per second. So friction is in this direction, so that it this friction prevents the slipping of the car along downward. And at now we get first B answer, because velocity equal to, at this velocity friction is 0. So for answer for the answer of B, friction equal to 0. Now 5 less than 10, so friction act upward. And what is the friction force? We cannot mu into n. N is, suppose n is mg cos theta, so this is not, we cannot calculate by this formula, f equal to mu n. So student generally make mistakes that friction equal to mu n equal to mg cos theta. This is not correct, because here velocity is less, so friction will adjust itself. This is not minimum velocity and not maximum velocity. We apply f equal to mu n when we get minimum velocity and maximum velocity. Remember this, we apply f equal to mu n for minimum and maximum velocity. We cannot apply f equal to mu n at this velocity, and at this velocity. So we cannot apply, because friction is adjusting force. Friction may take any value. So suppose this value is maximum, friction can adjust itself. So friction take any value. We are asked to find minimum velocity and maximum velocity, then we can apply mu into n. But here friction takes any value, so we have to here we have to find friction from this equation. We have to find, here friction is not equal to mu n. So students make mistake generally, friction equal to mu n mg cos theta, but this is not correct. This one will not correct. Friction equal to, here not equal to mu n. So we have to find the friction from this equation. Now So f into sin theta, now put tan theta equal to now tan theta equal to half. From this we get sin theta cos theta. This is theta, sin theta, this is root over 5. So sin theta equal to 1 by root over 5. So f into sin theta 1 by root over 5 plus n into cos theta equal to 2 by root over 5. 2 by root over 5 equal to mg. Weight equal to 200 into g 10 and mv square by r, that is 200 into v square, that is 25 r equal to 20 plus f cos theta equal to 2 by root 5 equal to n into sin theta equal to 1 by root 5. So now the n minus this equal to this, balance this. So from this we write f n into 1 by root 5 minus 2f by root 5, this minus the equal to this. Okay, now this equation we can solve 1 and 2. We can solve 1 and 2 by solving 1 and 2 we get the friction force and normal reaction. We get the normal reaction and friction force by solving 1 and 2. We get f and n. This is now for 20 meter per second. When velocity is maximum, then we reverse the friction force here, because v equal to root over rg tan theta. From this we get v equal to 10 meter. After 10 meter per second, velocity 20 is greater than 10. So now friction force act in this direction, because here centrifugal force is more, so friction force act along this direction. So when the friction act along this direction, what is the equation? Will be more value mv square by r. This normal reaction act in this direction, weight act in this direction, so centrifugal force in this direction. Now resolve n along two direction, this and this. So this is theta, n cos theta, n sin theta, n cos theta, n sin theta, mv square. Now friction act in this direction, so friction act in this direction. Now resolve friction along two direction, this and this. This is f, this angle is theta, so this is f cos theta, and this is f sin theta. So here n cos theta balance f sin theta plus mg and f cos theta plus n sin theta balance mv square by r. So n cos theta minus f sin theta. Now don't put f equal to mu n. I tell many times that don't put here f equal to, here don't put f not equal to mu n. So here f not equal to mu n, don't put here f equal to mu n. So now n cos theta minus f sin theta equal to mg and f cos theta plus f cos theta equal to mv square by r. Here n cos theta, n sin theta, so this plus this balance this force. So this f cos theta plus n sin theta balance this force, and n cos theta balance this plus this. So divide n cos theta minus f sin theta equal to this, and this plus this equal to this. So now put cos theta and sin theta tan theta equal to half, so 1 by 2 root over 5. So sin theta equal to 1 by root over 5 and cos theta equal to 2 by root over 5 put here. So n cos theta 2 by root over 5 minus f sin theta 1 by root over 5 equal to mg, mass equal to 200 kg, 200 into 10, and n sin theta n 1 by root over 5 plus f cos theta equal to 2 by root over 5 equal to mv square by r. So 200 into v square equal to here 400. Okay, 20 square 400 by r means 20 meter, that is 4000, here 2000, here 4000. So by solving this we get f equal to this. For solving this, n have to cancel. So if we multiply 2 and subtract this from this, we get f. So multiply 2. So now you can solve this by simultaneous equation you can solve this. So this is equation 1, this is equation 2, and if we multiply 2 into 2, then 2 into 2, so this will same, this will be same. Now you can subtract this, so you get this. So this is the this solve is left for you. You can solve this two equation, you can solve two equation, this type of equation you can solve this. So you can solve this. So this is the same methods. This is x, this is y, x, y. You can solve this. Okay, simultaneous equation, by simultaneous equation you can solve this. So this is left for you. Now one thing is that one things is that when the car turns in plain smooth banking road, when the car turn in banking smooth road, banking smooth road, what is the maximum velocity? V equal to, we get root over rg tan theta. Now this is the for this velocity the car can take turns, with same velocity. Now if velocity is less than that velocity, if v is less than root over rg tan theta, and if v greater than root over rg tan theta, what happens? So if the car moves with this velocity, then then the car can take safely turn, then the car can turn safely. But if the velocity less than or greater than, what happens? So here theta is fixed, here theta is fixed. If v less than root over rg tan theta, what happens? That is, if v is less, then v equal to, if v is less, then r should be less. That is, when velocity is lower, the car get down along the inclined plane. So the radius r is small. And when v greater than this, when v is more, then r should be more. So when v is more, then the car goes up along the inclined plane, so that r is more. Okay, that is v as the car change its velocity, the car just move this and this direction. That is, the car moves along the inclined plane down and up, If v is less than, then it goes down, and if v is high, then it goes up along the inclined plane. Okay, now car along smooth along plain road. So when he take turn in road, now he leans towards with vertical. He leans. Suppose this is a road. When a cyclist turn, suppose this is a wheel of the cycle. This is the normal direction of cycle. Normal direction on the wheel by the ground. So this is normal direction. Now if the cyclist lean theta with the vertical, what is the different equation? Weight of the cyclist act in this direction, and mv square by r act in this direction. When he take turn, this centrifugal force act in this direction. So if we resolve n along this and this component is n cos theta, and this is n sin theta. For cyclist, n cos theta balance the weight, and n sin theta balance the centrifugal force, mv square by r. Okay, now divide it 1 by 2, we get here also tan theta equal to v square by rg. That is, v equal to root over rg tan theta. If velocity is more, if the cyclist wishes to increase his velocity, then r should be more, that is he turn with great radius, with great it that is he turn with more radius. And if he with if he want to turn with less velocity, then r should be less. Okay, if you want to turn with more velocity, then r, that is turn of circular, that is the radius of circular turn must be more, because this should be balanced by this term is should be balanced by this. So v is more means r is more, v is less means r is less. Student, this is the end of the class today. To get such type of video, subscribe my channel. Okay, thank you.